The purpose of this lesson, interpreting quadratic functions, is to give you the background you need in order to be able to interpret quadratic functions. So make sure that you are really paying close attention to this because it will help you answer the assignment questions that you have that go along with this lesson. So before we move on, you need to understand what the domain of a function is and what the range of a function is. Don't forget that a function is a relationship in which each input has only one output. So the domain is going to be the set of all inputs. Okay? And then the range is going to be the set of all outputs. So for example, if you have a function that looks like this, I'm just randomly choosing values 2, 5, -3, 7, and 0, 5, for example. That would mean that the domain would be all of my x values right inside of here. So it'd be 2, -3, and 0. But when I write my answer out, I have to write it from least to greatest without any duplications. So my domain would be -3, 0, 2. Just like we would do in our mapping. We would go from least to greatest without any duplications. And my range would be 5 and 7. And I would only write the 5 out once because it's already indicated in my set. So I don't have to write it out a second time. All right, so in order to be able to answer this question, or the questions on the bottom of my paper, I need to be able to graph the following function and identify the key features of the graph. So remember, the 4 key features that we want are the roots, the axis of symmetry, the vertex, and the y-intercept. So the first thing I'm going to do is I'm going to find the roots. So I know that f of x equals 2x squared plus 2x minus 4. Sorry. So I'm going to set it equal to 0 to solve for x. I'll factor out a 2, so I get x squared plus x minus 2. So then I end up getting 2 times x plus 2 times x minus 1, which means that my roots are -2 and +1. Okay, now that I know what my roots are, I just have to average them together to find the equation for my axis of symmetry. So I'm going to go ahead and do that. I'm going to take -2 and +1, and I am going to add them together and divide it by 2. So I end up getting -1/2, which means that my axis of symmetry is -1/2. Okay, or x equals -0.5. So now I've figured out 2 of my 4 key pieces of information. Next thing I have to find out is my vertex. So I'm going to figure out what f of -0.5 is. Remember, I can take that and just plug it right into my calculator. So make sure to open up a calculator document, store -0.5 in as x. Okay, and then type in what f of x is equal to. So I'll type in 2x squared plus 2x minus 4, and that means that f of x is equal to -4.5, which means that my vertex is going to be -0.5, -4.5. Okay? So that's my third of 4 key pieces of information. The last piece of information that's going to be helpful for me is the y-intercept. Now for the y-intercept, I just want to make sure that everybody is 100% completely clear about why the y-intercept is the way that it is. It's technically the c value, so if you look at your equation, it would mean that it would be 0, -4. But I just want to double check to make sure you guys really get this. All I have to do is really figure out what f of 0 is, because the y-intercept always happens when x is 0. So it'd be 2 times 0 squared plus 2 times 0 minus 4. These cancel out, and that's why f of 0 equals -4. Okay? Now, based on my information that's given to me, I can go ahead and graph out my function. I need to figure out how I want to space out my x and my y axes. I know that my roots are going to go from -2 to +1, and my axis of symmetry is in between, so I need to space my x and y axes out so that I make sure that I cover all x values from -2 to 1. So let's go ahead and figure out where that's going to go. I also need to figure out what y values I need to go from. And I know my roots occur at 0, so I have to have 0 included. And I know my y-intercept is -4 and my vertex is -4.5. So I'm really only concerned about the negative x values for my y values in this specific example. So if I were to go ahead and graph it out, I will put it so that my x-axis is up high. Oops. So that my x-axis is up high so that I can make sure that I can cover the values that I need to cover. Okay, so I'll put my x-axis there, and then I'll just put my y-axis. Basically, I'll try to center it as best as I can. Again, don't forget to label your x and y axes, and then we're also going to have to number them. So I'll label this x right here, label this y right here. I know that 0 goes right there. I need to make sure that I get down to -4.5, so I will count each 2 as a whole integer. So -1 would go right here, -2 would go right here, -3 right here, so on and so forth. So I'll put my -3 right here, -4, -5, -6. All right, and then I will also do the same thing with my x values. I'll go up by halves. So I'll put my 1 right here. Okay, I'll put my 2 right here, so on and so forth. This is 3, -1, -2, -3. Okay, and then I will go ahead and plot out my points. So I know my roots are at -2 and +1. I also know that my y-intercept is at -4, and that my axis of symmetry will be at x equals -0.5. So I'm going to go ahead and graph that out for myself right here. So here's -0.5, and then I know that my vertex will occur at -4.5, so I'll go ahead and put my dot right at -4.5. Here's my other point of symmetry right here, and then I can go ahead and graph out my parabola. So this right here is my parabola right here, if it lets me graph it out. Okay. And then I'm going to say f of x equals 2x squared plus 2x minus 4. And there is my graph right there. Now, let's just make sure that it's okay on our graphing calculator. So go ahead and please insert a graphs page. I'm going to adjust my window first. So go to Window, Zoom, Window Settings. If you look at the graph that we have, it went from -5 to about +4, so that's what I'll say, -5 to 4. We'll go up by ones, and then on my y scale it went from -8 to about 2, so we'll go from -8 to 2, and we'll go up by ones. So my scale is good now, my window is good, and then I'll type in the graph, 2x squared plus 2x minus 4, and there's my graph right there. So it looks pretty on par with what we want right here. So the next thing that I'm going to do is I'm going to use this information to answer some questions for myself. So the first question that's being asked of us is, what is What is the domain of f of x? So the domain is all the x values that work. All right. So if I were to look at my graph, I'm going to see what x values work. Now remember, this parabola goes on forever. So this parabola goes on all the way to negative infinity, and it goes on all the way to positive infinity, which means that every single x value on this graph will work. So that means that the domain of my function is going to be all real numbers. That's one way to say it, okay? Or I could say negative infinity to positive infinity. It's your choice how you want to say it. So I'm going to say all real numbers, and this is the symbol for real numbers. Or I could say negative infinity to positive infinity, okay? And then it asks me, what is the range of f of x? So in order to figure out the range of f of x, I have to look at my graph again. And my graph goes down, starting from positive infinity way up here, goes all the way down until I get to my turning point, and then it starts to increase again, which means that the lowest value it will ever reach is your y-intercept, or excuse me, is your vertex. So go back and look at what your vertex was. The vertex was negative 4.5, which means that's the lowest point it will ever reach on my graph. So that means that my range is going to be from negative 4.5. Now when you do this though, you need to make sure that you write it so that it includes negative 4.5, because it does reach negative 4.5. So I'm going to use open brackets, and then it goes all the way to infinity, okay? For what values of x is f of x increasing? So right here, from the top all the way down, this is going down, 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 so it's decreasing until I get to my turning point. At my turning point, it's neither increasing nor decreasing. So from my turning point on, it's going to be increasing. So my turning point starts at the vertex right here. Remember, it says for what values of x is f of x increasing. So in this specific example, the turning point occurs at the axis of symmetry, which is negative 0.5, or the first half of your vertex. So from negative 0.5 on, my values of x are, or my values of, those are the values of x in which f of x is increasing. So I will say negative 0.5 all the way to infinity. Okay, so what values of f of x, for what values of f of x is f of x decreasing? So let's take a look at this right here. It's decreasing starting from negative infinity all the way until I get to my vertex. So it occurs at the x equals negative 0.5 value. So I'm going to say right here that it is decreasing from negative infinity to negative 0.5. So negative infinity to negative 0.5. All right, we're going to skip question number 5 and just go on to question number 6. It asks us to find the average rate of change from negative 2 to negative 1. So I want to know how much my graph is changing on average by from negative 2 to negative 1, which is very similar to finding the slope of the line, or of the segment from negative 2 to negative 1. So in order to do that, I need to have my coordinates from at negative 2 and at negative 1. So in order to find the coordinates, you would go to Menu, Analyze Graph, and then, Menu Trace, Graph Trace, and I'm going to figure out the coordinate at negative 2. So I'm going to go, so that's my first coordinate. I know that it's going to pass through the point negative 2, and then it went to 0, okay? And we should have known that anyways because it is a root. And then I'm going to figure out what it is at negative 1. All right, so I'm going to graph trace it again, negative 1. So negative 1 would be from negative 1 to negative 4. All right, so those are my 2 points that it goes through. Now if you look at it, my rate of change, I'm going to just zoom in on it so you can see it a little bit better. So I'm going to go to Window Zoom, and then I'm going to go to Window Settings again, and let's try this again. Menu, Window Zoom, Window Settings, and I just want to look at it from negative 2 to negative 1 because that's what the interval says. So I want to know how much it's changing by from here all the way to here, and in order to do that, it needs to, and it will be decreasing. the rate of change will be negative because it's decreasing. So I'm going to use the slope formula, and I'm going to plug my information into the slope formula. Now the slope formula is going to find the change in y, so negative 4 minus 0, over the change in x, so negative 1 minus negative 2. So I end up getting negative 4 over 1, which means that my average rate of change from that interval is negative 4. Okay? So that's what the rate of change is going to be. And we're going to be using that to actually answer some questions where we're interpreting functions. But I needed you to understand how to actually find the rate of change.